Hey, good people. I hope all is well. This is Arthur Morris. In this video, we're going to look at simplifying using the simplifying quotient of expressions that involves exponents. Quotient of expressions involving exponents. We're going to look at simplifying those. So again, we're going to use the quotient rule here, and the quotient rule, as we stated before, says that if I have like basis in the numerator and denominator, to simplify those bases, we subtract. Let's just take a minute to look at why the quotient rule is true. If we expand x to the third over x squared out, x to the third means x times x times x. X squared means x times x. And then if we simplify that, we can simplify an x for an x in the numerator with an x in our denominator. And you see that we have only an x, single x left in our numerator, x to the first. Well, if you look at this and subtract, x to the third minus 2, 3 minus 2 in our exponents is x to the first. Same answer. So it's a shortcut there. Shorter way of simplifying those. So we'll do the same thing. One other thing you want to keep in mind, another exponent rule, is that if you have a negative exponent, whether it's in your numerator or denominator, to rewrite that as a positive exponent, you move it from whatever place it's in. So if it's in the numerator, you move that base to the denominator, and it makes the exponent positive. If you have a negative exponent in your denominator, then you move that base to your numerator to make it positive. Okay, so just a refresher on that negative exponent rule. All right, so with this first problem, we have y squared and z to the 6th in our numerator. And then our denominator, we have 5 times y squared times z to the 5th. All right, so that's an understood 1 in that numerator. So if you're looking for a number there, it's understood to be 1. You don't have to have it there unless there's nothing else in the numerator. Okay, so let's start with the y's. So we see we have y squared in our denominator, so let's just rewrite this to subtract the exponent, moving it up and subtracting. Same thing with the z. We're going to take this 5 from our denominator and subtract it from the 6. Okay, using our quotient rule. So that gives us y to the 0 power and z to the first power all over 5. Now remember, any variable raised to the 0 power, anything raised to the 0 power is equal to 1. So that's just 1z, or z over 5. So anything raised to the first power is equal to 1. So that's just 1 times z, which is z all over 5. So you got to learn those exponent rules. Alrighty, let's look at another one. Alright, so this one we have y times x to the 7th times a to the 5th all over y to the 4th times x to the 3rd. So again, we're going to use our quotient rule with the y's and the x's. The a to the 5th, we don't have another variable, another a variable, so it'll just stay where it is, like it is. We won't change anything with the a. But with the y, and remember this y in our numerator is understood to be y to the first. So if we were, this is what we're thinking, and you don't always have to write this out, but we're thinking take the 4, subtract it from the 1 that's in the numerator with the y's. For the x's, take the 3, subtract it from the 7, and then a to the 5th. So since we did not have anything else in our denominator, then we won't have a denominator right now. We subtracted, took care of the y to the 4th by subtracting it from 7. We took care of the x to the 3rd by subtracting it from, we took care of the y to the 4th by subtracting it from the y to the first up here, and then the x to the 7th by subtracting it from the 7. X to the third subtracted from the 7. I'm sorry. So now we just want to simplify this. So let's go out to the side here. So 1 minus 4 is negative 3. And then 7 minus 3 is 4. All right, so the only thing that we don't want would be negative exponents. So we don't want to keep negative exponents. We want to make those positive. So we're going to use that rule that we just looked at that says that if we have a base with a negative exponent in the numerator, then we take that base and move it down to our denominator to change the sign of the exponent. So the x to the 4th and the y to the 5th would stay, or a to the 5th would stay in the numerator. And then the y to the negative 3rd, we're going to move that base to our denominator to make that exponent positive. And then that will give us our answer. So x to the 4th times a to the 5th all over y to the 3rd. Again, so what we did, we used the quotient rule. We said y to the 1st over y to the 4th, 1 minus 4, y to the 1 minus 4, and then x to the 7th over x to the 3rd, x to the 7 minus 3, and then keeping the a to the 5th. 1 minus 4 is negative 3, so we had y to the negative 3rd, which we then moved to our denominator to make that exponent positive. All right, let's look at one more. All right, so here we have x to the 6th times z to the 4th over x to the 5th times z to the 1st. So again, we will use our quotient rule. So we have x to the 6th minus 5, because we had this x to the 5th in our denominator. Remember, that's understood to be z to the 1st in our denominator. And then take care of that. Now we have z to the 4th minus 1. Just subtracting the exponents. And you can do that part mentally. You don't have to write it out. So x to the 1st times z to the 3rd. We don't have any negative exponents. Everything is fully simplified, and we're done. Alrighty, good people. Keep practicing. I hope you found this video to be helpful. Thank you.